So when we talk about group 13 elements, boron family, naturally we call it boron family because boron is the first member. Group 13, 1C13 according to the new nomenclature, 3A according to the old nomenclature, NH2 NP1 is the general configuration, boron is the non-metal, is very rarely found. B11 is more abundant, this is almost 80%, 81%, this is 19%. Aluminium is the third most abundant, this is the third most abundant and the most abundant metal, most abundant metal. So the third most abundant after oxygen, then silicon, then aluminium. You know, this is the order of abundance of elements on the planet. I repeat one last time. I hope I am being heard. You all can hear me loud and clear. But chalo, I'll name the popular ores of boron and aluminium. Again, before I go there, gallium, indium, thallium are very less abundant. They are very less abundant. Obviously, down the group, metallic character increases, so they're going to be metallic. And nihonium is radioactive, synthetic, T half being very, very small, which is 20 seconds, is what makes the study of nihonium impractical. The common ores are the source of boron happens to be boric acid. Then Na2B4O7, Na2B4O7.NH2, what's the common name of this compound? Na2B4O7?
Borax.
Borax. And there is another hydrated form of Na2B4O7, which is called kernite. This is naturally borax, the more popular decahydrate form. The other one is called kernite. I've told you about the electronic configuration. And let's talk about the periodic properties now. So a little bit about the periodic properties, and then I'm going to directly jump to the notes which I've shared with you. In periodic properties, I mean, you just want to confirm me once if this is better or if I switch this off, it's better now. Oh God. If I switch this on, it's better. Is it better now?
Yes, sir. Yes, sir.
I'll just do it one more time. Is it better now? Or is it better now? I think with the light switched on, the glare is increasing. With lesser light, it's more visible. All right. Yes, you can carry on. Anything you want me to repeat? Electronic configuration, and now we'll talk about the periodic properties. Now, when it comes to the periodic properties, the most common being size or radii. You know, you have an anomaly right away. Boron, aluminium, gallium, indium, thallium, and you'll find aluminium is bigger than gallium.
Slightly bigger.
Yes, please.
बहुत कम difference होता है.
I mean, down the group, you expect size to increase, but when it comes to boron, aluminium, gallium, indium, thallium, one thing I've told you in the past, one difference between, you know, what happens between aluminium and gallium is largely because before gallium, you have 3D filling. Again, before thallium, you have 4F filling. So 3D, poor skinning effect, lanthanide contraction, and all will play its part. So down the group, the increasing size decreases, and actually it's quoted in NCRT as well. The radii of gallium is given as 135 picometer, for aluminium it's given as 143 picometer. It's not like you'll have to know these numbers, but because it's there in NCRT, it's very clearly mentioned that aluminium is bigger than gallium. So many sources would say the sizes are comparable. Ionization energy, and yet again, boron, aluminium, gallium, down the group it should decrease. But gallium का aluminium से ज्यादा होता है और thallium का भी indium से ज्यादा होता है. I think, ionization energy, gallium more than aluminum is about increased protonic charge and poor skinning effect. So the outermost electrons are more tightly bonded. One way or the other, you'll want to take a note of this because these are some discrepancies and could be some questions in the advanced exam. What they do in advanced exam is they talk about things which are a little uncommon. It does not happen in JEE mains, but in advance, they will talk about things which are uncommon. And because the entire list is given in table form in NCRT book, the overall order, which is boron, thallium, gallium, aluminum, indium, boron, thallium, gallium, aluminum, indium, somewhere, you'll want to remember this. You'll want to take it down somewhere, some way or the other, you'll want to remember this. I think you're noting it down, and we'll want to quickly move to the next periodic property, which is electronegativity. I'm going to keep it short. I'm only going to talk about the ones which are prominent and likely to come in the exam. Electronegativity, the overall order is boron, thallium, indium, gallium, aluminum. So here again, down the graph, it's supposed to decrease, it's supposed to become more and more electropositive. But the anomaly is largely because the discrepancies in atomic size. It decreases from boron to aluminium, then increases. Decreases from boron to aluminium, then increases. So these are a few things you'll want to know. Again, this is because of the size discrepancies. And we'll want to switch off from periodic properties and move on to the notes which I have shared with you. I think I'm being heard. I think you're noting down everything. बच्चे लोग हाँ ना बोलो.
Yes,
sir.
sir.
Fair enough. Can I move on? Can I move on? Some way or the other, you'll want to remember this because it's there in the form of a table, in the NCRT. I told you when it comes to the advanced exam, there is a likeliness of asking things which are a little uncommon. Gallium smaller than aluminium is a known fact, and some discrepancies here and there. Again, between thallium and indium, ionization energy is opposite because before thallium we have 4f filling, which has very very poor skinning effect. Between indium and thallium, the effective atomic number will increase by 32. And all of this is given in form of a table. It's completely tabulated in NCRT. I'm not talking about all the properties, but the ones which are, striking have to be known. Other than boron, the rest are supposed to be metallic with conductivity and all. Yes, we can move on. And now, as I told you, I'll take up. It's going to help. It's going to help, if you have all of it in the printed form. In the sense, ideally, you'll want to take a printout and then, note down or mark the key points that I keep on saying. Obviously, it's not possible to start writing it down. I could also do this, thanks to the Corona period. But the list you'll want to do is know that boron is a non-metal, extremely hard, black-colored solid, exists in 5 allotropic forms, 4 crystalline, 1 amorphous. Now, this is obviously this is much more than NCRT. This is much more than NCRT. Keeping all the other exams in mind, I have populated maximum information. So all crystalline forms are hard, made of B12 units, black and chemically inert, high temperature, attacked by strong acids like sulfuric acid, nitric acid. Amorphous form is brown and chemically active. This is again there in NCRT. I missed out on one particular name, which is colemanite. Borax is the popular decahydrate form. Kernite is the tetrahydrate form. Boric acid is something which you know. When it comes to obtaining boron, the most popular way is reduction of B2O3. Now, reduction of B2O3, so you'll want to obtain B2O3 from borax or boric acid. See, this is in principle what's going to happen. This is in principle what's going to happen. Eventually, you'll reduce B2O3 to boron. So this is simple reduction. And these are like methods of getting B2O3 from borax or boric acid. Boric acid, please take a note of it. Boric acid initially forms metaboric acid. It initially forms metaboric and then it forms pyroboric. Know these names as well. HbO2 is metaboric. इसी का salt होता है sodium metaborate, which is a component of the borax bead test. B2O3 is very popularly called boron trioxide से ज्यादा ना इसका popular नाम है it's called boric anhydride. It's called boric anhydride. Naturally, you remove water and you get B2O3. So I recommend it's a simple common heating effect. So you'll want to know it. Again, BF4 minus the salt on heating can give you boron. So on hydrolysis, borax will give you H3BO3. Again, this is not hard to believe because this is a salt of strong base and weak acid. That weak acid is boric acid. This is the heating effect, and eventually you get boron by reducing B2O3. So at your convenience, you'll want to know these key points. Again, Van Arkel process is something which I do talk of in metallurgy. Such an important topic which is unfortunately not there in the mains and the school syllabus right now, the board syllabus right now. But Van Arkel process is something, which is heating the iodide and, getting boron. Boron halide on reduction gives you boron. Is the way to get pure boron. So a couple of methods again you still want to know. Properties, boron reacts with NaOH. These are more popular reactions. So it becomes sodium borate. With sulfuric acid, nitric acid at high temperature, it gives you boric acid. So this is again understandable. It's like getting oxidized to boric acid. NaOH के साथ में sodium borate is the corresponding salt. Borite on hydrolysis giving you B2H6. Now, B2H6 has to be an extremely important molecule. This is very, very important. Along with its structure, which is a very unique bridge bonding wala structure. I'm going to talk about it in details. ये ऐसा चार एक प्लेन में रहता है. ये चार एक प्लेन में रहता है. And naturally उसके बाद ये हाइड्रोजन और ये हाइड्रोजन के साथ जो बॉन्ड होता है उसको बनाना बॉन्डिंग का ऑर्बिटल में रखता है. So I'm going to talk about its structure in detail. Along with ये चारों same plane में रहता है. These four are planar. These four hydrogen are planar and these two are above and below banana shaped orbitals. B2H6 from structure to properties is extremely important. How do you get boron? Commonly from a borite, and boron on hydrolysis gives you boric acid. Are two informations which will be very handy. We move on to this general discussion. This is something which I would want you people to know. Boron are analogous to alkane. They are naturally the hydrides of boron. 20 borons are reported, 11 are well known. A couple of things which is like, as I told you, beyond J means there are two typical formulae called nidoborans and arachnoborans obeying BNHN plus 4 and BNHN plus 6 rule. Diboron is certainly the most common. And then the way of naming it. So B5H9, which belongs to a BNHN plus 4 kind of a formulae, you call it pentaboran 9. So naturally, it's pentaboran means 5 boron and 9 would mean the number of hydrogen atoms, whereas a pentaboran 11 would make it B5H11 and belong to the category of BNHN plus 6. So, there's something again, which you'll want to have an idea of. Talking about properties of diboron, sooner than later, I think I'm being heard. Somebody would want to respond so that, I can move with a little more conviction. Somebody will want to respond and I'll want to move with a little more conviction. I think I'm being understood.
हाँ सर.
Yes, sir.
डाइबोरेन में ये जो 12 वैलेंस इलेक्ट्रॉन्स का बात होता है ये मैं बताता हूँ. 2 बोरोन में इवेंचुअली 3 3 करके 6 वैलेंस इलेक्ट्रॉन होगा, और 6 हाइड्रोजन में 6 इलेक्ट्रॉन होगा, तो टोटल 12 वैलेंस इलेक्ट्रॉन समझ में आता है। ये 12 वैलेंस इलेक्ट्रॉन से इतना बॉन्ड नहीं बन सकता। Now what I have done is I have made these four in a plane and these four, out of it. In reality, a textbook is, the textbook is more commonly going to say that these four are in the same plane. These four are in the same plane. These four are coplanar, and these two are like above and below the plane. So that's understandable. I've deliberately given a formula where I would want these to be in the frame because in the plane, because I'm going to talk in details about it. ये सब नॉर्मल दो दो इलेक्ट्रॉन वाला बॉन्ड है, जो नॉर्मल नॉर्मल दो दो इलेक्ट्रॉन वाला कोवेलेंट बॉन्ड. So 2468 is out of 12, normal covalency is exhibited. 4 terminal bonds are, 8 is the normal overlap of bilateral sharing of electrons, Lewis dot structure, everything which you know about covalency, normal covalency. And this entire stuff is made up of 2 electrons. That is why it's called 2 electron, 3 center. 3 center 2 इलेक्ट्रॉन, ये जो नाम है ना 3 center 2 इलेक्ट्रॉन, ये 3 center के ऊपर में 2 इलेक्ट्रॉन है, इसी को बनाना बॉन्डिंग भी बोलते हैं, ब्रिज बॉन्ड भी बोलते हैं, बनाना बॉन्डिंग भी बोलते हैं. बनाना बॉन्डिंग बोलते हैं बिकॉज बनाना 6 ऑर्बिटल्स होता है. हिंडर्ड रोटेशन. अब इलेक्ट्रॉन डेंसिटी इसमें ज्यादा, इलेक्ट्रॉन डेंसिटी इसमें ज्यादा है, इसका बॉन्ड एनर्जी ज्यादा होना चाहिए. बट इंटरेस्टिंग बात है कि व्हेन यू सब्जेक्टेड टू अ रिएक्शन लाइक पॉपुलर वन इज मिथाइलेशन, पहले ये बॉन्ड टूटता है. जनरली व्हाट वी बिलीव इज अ वीकर बॉन्ड इज मोर लाइकली टू ब्रेक. Naturally, this covalent bond, which is the normal terminal bond, will have more electron density and will have lesser bond. I'll have to check if the bond lengths are given in NCERT or not. Give me a while. I'll have to check if the bond lengths are given. I can see the bond lengths are given, but not of B2H6. They have given it for boron trichloride का dimer. तो B2H6 का, yes, B2H6 का भी है. 119 picometer and 134 picometer. So as expected, this is 134 picometer. This entire length is 134 picometer. And this is 91 picometer. So as expected, this with more electron density will be smaller. But as we move on, we realize that the bridge bonds, despite having more bond length, are difficult to break. So these are information which you'll want to have. B2H6 cannot be methylated beyond B2H2 M4, which means all the 4 BH terminal bonds have been methylated first. And if you go about exhaustively methylating it, then it will break. It will break into B and E3. Now, they're used to form higher boranes, organoboranes. They're reducing agents, they're reducing agents. We've had our experience with boranes acting as reducing agents. So these are things which we have known: cyanide to amine, nitro to NH2, B2H6 in alcohol is another reducing agent, say after lithium aluminum hydride, NeBH4, and dibyl H, which is largely for aldehyde. So this is known to all of you. A boride will give you a mixture of boranes, mainly B4H10. On heating in sealed tube, various boranes are formed. So the next important fact I reckon is B10H14 is inert in air. ये कहानी एक है. ये कहानी में कभी-कभी क्लास में भी सुनाता था. At one point of time, boranes were considered as possible high energy rocket fuels, and it was thought that they'll replace hydrocarbon fuels. अमेरिका रॉकेट फ्यूल्स के लिए ऑलमोस्ट 1 टन बोरेन बना करके, it did not work because unlike carbon monoxide, carbon dioxide, which are like very stable, boron oxides will polymerize and they'll jam, block the nozzles of rocket, and there were other technical problems. But at the end of the day, what we know is burning borane is very, very exothermic. That it is a colorless gas, highly reactive, catches fire in air. There are special, taps meant to, store B2H6. Extremely reactive on hydrolysis of the forms boric acid. Plus heat, I've deliberately written plus heat, encircled because you'll want to know it's an extremely exothermic process. Its role in hydroboration oxidation to carry out anti-MR oxidation, which gave this man a Nobel Prize in chemistry is again a story which I keep on telling you. Now, this forming adduct with NH3 is important because the two adducts, borane plus ammonia, the two adducts which you get, borane plus ammonia, the two adducts which you get are extremely important. Boron nitride, which is going to be called inorganic graphite, and B3NCH6, which is going to be called बोराजिन और बोराजोल एक ही होता है. बोराजिन और बोराजोल सेम होता है. जैसे ग्लिसरीन और ग्लिसरॉल सेम होता है, बोराजिन बोराजोल सेम होता है. टेम्परेचर ज्यादा होने से you get boron nitride, low temperature, and then further heating, you get borazine, borazole. I think the ratio at times, could be the determining factor. If the ratio is 2:1, then you get borazine. And if it's more than 2:1, you get boron nitride. White slippery solid made of hexagonal rings of boron and nitrogen, same structure as graphite, layer structure. This is again an interesting point. Boron का 5 वैलेंस इलेक्ट्रॉन होगा और मतलब 5 ओवरऑल इलेक्ट्रॉन भी होता है और नाइट्रोजन का 7 होता है. तो बोरोन और कार्बन के बाद नाइट्रोजन है, तो नेचुरली एक बोरोन और एक नाइट्रोजन मिला के सेम वैलेंस इलेक्ट्रॉन्स क्या सेम काउंट ऑफ इलेक्ट्रॉन्स भी होते हैं. टोटल काउंट ऑफ इलेक्ट्रॉन्स इन वन बोरोन एंड वन नाइट्रोजन इज इक्वल टू दैट इज 2 कार्बन एटॉम. So one boron and one nitrogen, ending up being analogous to all being carbon is how I relate the structure of boron nitride with graphite. Is how I relate the structure of boron nitride with graphite. Both are planar. Layered structure, planar, layered. I think I've used these terms. Layered structure, hexagonal rings. Borazine, inorganic benzene, because, very much like benzene, where you have an alternate arrangement of pi bonds, here I could say that this nitrogen has a lone pair and this boron is electron difficile. So yet again, I have tried to do, some kind of analogy between not only the flat planar structure, and in the process, I'll believe that, nitrogen ka lone pair is getting, involved in this back bonding. And with this getting delocalized, I just told you, a lone pair which is delocalized is never counted in the select number. I can claim all are sp2 now, Generally with 3 pi bonds, one lone pair will claim it to be sp3, but with this pi bond getting delocalized, it's going to look fairly sp2 throughout, planar throughout, and an arrangement like double, single, double, single, double. Boron sesquioxide, B2O3, ये जो नाम होता है ना sesquioxide, suboxide भी इसको बोलते हैं at times, suboxide. Suboxide or this particular name, sesquioxide, is actually for something which is going to exist in this form, in this stoichiometric form. B2O3, heating effect of boric acid. You see it a few times, 100, 160 degree kind of, is not something which you want to mug up. But as I told you, initially meta and then pyro. You have your own ways of recalling the sequence in which it's formed. When you put water to B2O3 again, this will be reverted in the same sequence. It will form pyro first, then meta, and then boric acid. B2O3 along with NaBO2 is the stuff which gives you color. NaBO2 फिर ना ये मेरे को BO2 का वैलेंसी याद रहता है, BO2 minus. So whether it's B2O3 or NaBO2 together forming the glassy bead in the borax bead test, I'm obviously going to talk about it. Vitamin B12 का क्या होता है scientific name? Does anyone know the scientific name of vitamin B12? Expected to know it. Yes, please.
Cobalamin.
Cyanocobalamin.
Okay.
Cyanocobalamin, and it contains cobalt for cobalamin. B2O3 is naturally acidic because it gives you a weak acid, boric acid, but with more acidic stuff like C2O5 and all, you can have this reaction happening as well. So it's not like you want to know everything. This is extremely, extremely important. This is very, very important. Right away, I do talk about boric acid at times. it behaves as a weak monobasic acid. It's very different from the normal acids in the sense it's not an areneous acid. It does not lose H plus. This is important. And instead of writing as a H3BO3, writing it at BOH whole size would make more practical sense. The H plus which you get by adding boric acid to water, the H plus and thereby the acidic nature of the solution is not the H plus which comes from boric acid. This H plus comes from water. Now, this is an interesting piece of information. It accepts OH minus. It does not lose H plus, it accepts OH minus. So again, a bit of information, you'll want to have at hand. It's a Lewis acid. It's obviously not tribasic. It's not tribasic. It's not tribasic. It's not tribasic because it does not lose H plus at all. So when it's not losing H plus, it's not about the count of H plus or hydrogen in boric acid. Again, the structure of boric acid would also look like it's boron with 3 OH, plain triangular structure, which with water would become BOH4 minus, and naturally the H plus which is coming is the H plus which comes from water. Borax becoming boric acid on hydrolysis is something which we saw in, now you can kind of remember. This on heating will give you B2O3, and this on reduction with a strong metal like magnesium, potassium will give you boron. So this is how you start building up, a few facts around you. Boron halides on hydrolysis giving you boric acid. I mean, constantly throughout hydrolysis, I tell you, if there is a positive and a negative end of a salt, naturally with water, the negative will take up the positive end of water, which will give you the hydracid, and the positive will give you the negative end of water, which will give you the oxyacid. So, things I've told you in the past, acidic property of boric acid, since it partially reacts with water to form. So I've had enough time during that corona period, and I could, write it down in a little more detailed manner. A sharp endpoint is not obtained, a sharp endpoint is not obtained. It's acting as a weak acid. But, if you can shift this equilibrium forward by adding a polyhydroxy compound. Polyhydroxy means having more OH groups, multiple OH groups. Glycerol is the simplest example. Mannitol or sugar, sugar is something from carbohydrates. So all polyhydroxy compounds except, I would have written somewhere, ethanol. Except glycol. It needs to be a cis diol. If this is stabilized, except ethylene glycol. See, I've written. Except ethylene glycol, any cis, it has to be cis. Ye cis hoga tab ek complex bana dega. I can say this is the conjugate base of BOH whole size acting as a Lewis acid with water. So the stability of this conjugate base would decide the stability of this conjugate base will decide the acidity of BOH whole size. So the acidity is raised, and you can have a sharp endpoint once you have treated it with a cis diol. Cis because it needs to have this complex form, structure of borate, sp2 hybridization. I don't think anybody has any trouble here. Boric acid contains triangular BO3 3 minus units in solid form, hydrogen bonding together, two-dimensional hexagonal symmetry are again information you'll want to have. And this is there in NCERT as well. At one time, boric acid was used as mild antiseptic, talcum powder, baby, fine powder, no longer used as sometimes causes वाला है. सब कहानी में सभी लिख दिया हूँ, पर ये NCERT में भी है. ये बोरिक एसिड का ये ट्रायंगुलर फॉर्म बना करके ये हेक्सागोनल स्ट्रक्चर जो है इसका, it's in NCERT as well. Orthoborate contains discrete borate like Mg3BO3 whole twice metaborate to form polymeric chains. Again, these are information. ये स्ट्रक्चर वाला चीज जो ना वो सिलिकेट से ज्यादा पूछता है, बोरेट से उतना नहीं पूछता है. Silicates का बात करेंगे maybe in the class tomorrow. I'm going to again give you a lot of notes on carbon family and all. So sequence will be boron family, then carbon family, then compounds of aluminium and all, and then metallurgy. Metallurgy के बाद सबका extraction देखेंगे, उसके बाद में problem solving करेंगे. Very important. Borax, extremely important. Very important. I think this is fairly readable. I guess you all have the notes with you around this time.
Yes, sir.
And as I told you, it's largely about around this period, knowing things and being able to, relate to it from the four options which are there. This is how you get borax. So there is a story of filtration by, taking out calcium carbonate with the precipitate. This Ca2B6O11, this Ca2B6O11, this colemanite only. This colemanite only. I would have written it in a particular manner for, this reaction to be understood. So 2CaCO3 is coming out, sodium borate is formed, you hydrolyze it, crystallize it, made up of two triangular and two tetrahedral units. This is very important. This is extremely important. Again, it's a question direct. Two triangular and two tetrahedral units are about this boron having 3 arms and this boron having 4 arms. So this is the triangular unit. This is the two triangular units we're talking about having 3 arms, and these are the two tetrahedral units. Tetrahedral units will be this one having 4 arms. So know about the structure. It's not like they'll ask you to draw this structure, but stuff like how many triangular tetrahedral units and all, would be within reach. It's a primary standard for titrating against acids. Methyl orange is normally used to find the endpoint and all. One more borax reacts 2 moles of acid because when borax is dissolved in water, BOH3, BOH4 minus are formed. Only BOH4 minus reacts with HCl. Borax is also used as a buffer. It's stacked for solution which contains equal amount of weak acid and salt. Are information which you'll want to have. Borax dissolves in water to give an alkaline solution, again being a salt of strong base and weak acid. And see, this is the borax bead test. I do tell you about the borax bead test in salt analysis only. I do this in salt analysis only. But this is the mixture which gives you the glassy bead. And generally the boron trioxide or NaBO2 would form colored borates. It would form color borates. Preparation of diboron is also given in brief. Inorganic benzene, borabin, trihalides. I think we're nearing the end of this particular stuff. The trihalides are important. Trihalides are important, and the most important part of trihalides is the question which is about, BF3, BCl3, BBr3, Bi3. They all have incomplete octane. Naturally, they are halides and covalent in nature. Bond length shorter than expected. Order of Lewis acidity is also reversed as expected. This is the most common question, the order of Lewis acidity. The incomplete octet will mean the lactate incomplete octet will mean they're electron deficient, and they'll act as electron deficient and thereby electron acceptor. Now, electron acceptor is a Lewis acid. Fluorine more than bromine is the electronegativity. So because of the electronegativity, I would consider BF3 having the most electron deficient boron and thereby expectedly the most acidic. See, I've written this down. Boron atom is donated in the order, this is about back bonding, and because it's about back bonding, the electron deficiency is taken care of. This is back bonding. I'll call it p-pi because p-pi से p-pi में ही होता है. और ये बैक बॉन्डिंग उतना एफिशिएंट होता है जितना ये जैसे 2p2p तो हम लोग बोलते हैं ना 2p2p के बीच में रेजोनेंस भी सबसे अच्छा होता है. We talk about fluorobenzyl. And here again, this 2p2p साइज जितना रिलेटेबल होगा, जितना क्लोज होगा, उतना एफिशिएंट बैक बॉन्डिंग होगा. तो बैक बॉन्डिंग से क्या होता है, इस बोरॉन का इलेक्ट्रॉन डिफिशियंसी, इसका इलेक्ट्रॉन डिफिशियंसी इज मैट. Electron deficiency is over. Expected order was BF3 more than BCl3 more than BBr3 more than IBI3. This was the expected order. Again because Chlorine more than bromine more than iodine is the order of electronegativity. And this being most electronegative would have turned boron to be the most electron deficient. But in reality, in BF3, this is the least electron deficient. Electron deficiency is less because of back bonding, which is most efficient in case of boron fluorine followed by boron chlorine. तो बैक बॉन्डिंग से इसका पेट भर जाता है, बैक बॉन्डिंग से इसका पेट भर जाता है, तो बाहर से इलेक्ट्रॉन लेने का टेंडेंसी कम हो जाता है, और बाहर से इलेक्ट्रॉन लेने का टेंडेंसी कम हो जाता है, तो एसिडिटी इज less and the order is reversed. The same, I think, is exhibited in its bond length as well, where it starts showing double bond character, back bonding ज़्यादा होने से bond length कम होता है. Best between fluorine, boron, and least between iodine and boron is again about, closer the size of the nuclei, better is the extent of back bonding. Please explain, please tell me one thing, if this is understood by everyone or not. I have complete P block noted down in this manner. So I would leave it to your intellect how much you want to write down. Writing down would not be practical, but again, taking a printout and attending these classes, asking your doubts would help you in the real exam. It's going to be a big paper, paper 1, paper 2, more questions, and in advance, plus other exams, expect inorganic chemistry to be much more than what was there in JEE. Certainly not limited to NCERT only. So at my convenience, maybe in an hour or two, I'll send you notes on carbon family. So when we meet tomorrow, we'll talk about carbon family, allotropes of carbon, some properties of diamond graphite, and the very, very important case of fullerene, including topics which are there in NCERT and beyond. So in all likelihood, I'll take the next class tomorrow afternoon. I was hoping that, I would take longer to complete this, but we're done for the today's stuff. Anything you want to tell me, you want to ask me? After a lot of P block and metallurgy, solid state is something which I have not done. So solid state playlist you can ask from me. You can solve problems from solid state in due course. But I guess this much for the time being. Ritisha, Jatin, Dak, anything you want to tell me? Yes, I'll see you tomorrow afternoon. I'll be sending notes on carbon family writing. Chalo, see you tomorrow. Go through the notes on carbon family which I'll share with you and catch you up tomorrow afternoon.
Okay,
Bye-bye.